Welcome to this month's FN network, and today we've got Paul Fox-Hughes from the Bureau of Meteorology, who's going to talk to us about where to from here with fuel moisture and a bit more about JASMIN and the work they're doing with soil moisture measurements and modelling. Thank you.
Thank you, Mike. I'll just bring my screen up. Okay, hopefully everyone can see that. Zoom tells me I'm sharing. So, okay, great, thanks. So I'll talk today, as Mike said, about where we've come from, where we are, and where we're going with soil moisture. And the pictures I've plonked into the title slide here illustrate some of the importance of having a good handle on soil moisture, as you know, everyone's aware, but I will expand a little on the importance in a minute, and talk about, as I said, where we've come from, where the historical basis of what we're doing currently, and the ways, or some of the ways in which things could look in the immediate and the sort of midterm future. And by midterm, I mean maybe sort of 5 years down the track. Sorry, the phone just in here just decided to go off right at that moment. And so what I'll be talking about in terms of the JASMIN work is very much driven by work that Vinod Kumar and Imtiaz Darzi at the Bureau have done as part of the bushfire and natural hazards land dryness project. So Imtiaz and Vinod are the people who've actually done the work here. I've just been the project manager in the last few years, but they've done some outstanding work in getting a system up, identifying its advantages and where it can go. So we're all pretty much aware, I guess, of the importance of soil moisture. Soil moisture gives a background or a source of moisture for vegetation, and so very strongly affects the flammability of that vegetation and hence the fire danger on any particular occasion or during any particular period. It's also got a strong importance for sensible heat in the environment, and in particular for heat waves, or the potential for heat waves to occur. So evaporation of soil moisture uses some of the energy that the sun provides in insulation. So as the sun's rays hit the Earth's surface, they can either cause the temperature of the surface to rise, and so the temperature of the air in contact with the surface to rise, or if there's soil moisture available, that soil moisture can evaporate, and some of the energy is used to cause that phase transition rather than heating the environment. Consequence of that is that most heat waves tend to be associated with dry periods. So heat wave, for example, that preceded Black Saturday was very intense and came at the end of the millennium drought. A lot of the heat waves that we experienced in Australia last year as heat moved basically around the continent over an extended period of time weren't associated with the really dry few years that occurred then, and of course that preceded the fires last summer. The flip side, of course, is that if your soils are saturated, then there's limited or no capacity to absorb moisture that might fall in heavy rain. So you get enhanced runoff and a greater potential for flooding, and actually it's even more tricky than that, because if you have very dry soils and a period of rapid heavy rainfall, then because the dry soils can be hydrophobic, then you end up with a lot more runoff than you would expect, even given that it's a heavy rainfall situation. And we've seen that a number of times. You know, the footage we saw of over in Australia of the California mudslides and floods last year were, you know, at least in part a consequence of a antecedent very dry period. The 2016 fires in Tasmania, we saw exactly the same sort of thing, where we had very heavy rainfall on the north coast of Tasmania after a very dry period during which the 2016 fires occurred, but much of the heavy rainfall ran off, caused problems for the community, but didn't actually wet the soil very much. So the upshot of all that, of course, is that soil moisture is an important parameter that we should keep tabs on. And you know, people obviously have recognised that for a long period. Historically, we've only been able to estimate soil moisture at sites where we've got daily rainfall and temperature measurements, and so those are fairly limited across the landscape. And furthermore, because of the way, because of the lack of computing power, people were required to hand calculate the estimates of soil moisture that were made, and those estimates were made using available weather data, which, as I say, was generally just daily rainfall and temperature. So they're limited indices with limited scope over a limited area, in a sense. And today, we're still basing our systems pretty much on those, even though they've become slightly more sophisticated. And there are a couple of examples there, for example. So in Tasmania, the Soil Dryness Index gets used. It's based on observations made at 80 or 90 sites that are then interpolated across the landscape. Similar sort of thing in other locations. So the KBDI in this is just one that I grabbed yesterday, New South Wales, a similar sort of thing happens. So that point-based observations are interpolated across the landscape. We also have model-based systems that use the gridded rainfall and gridded temperature to calculate those same parameters of SDI or KBDI, but the calculations that are performed, even though they're done on high performance computing, they're still those very basic calculations that were done, the same way that they were done in the 1960s and 1970s. So it's the same underpinning algorithms and estimates of soil moisture that are being calculated there. But also today, we've got a number of other systems or approaches starting to make their presence felt. So at the moment, as a result of a large amount of hydrologically based, if you like, funding that the Bureau got about a decade ago, the Aura system was developed, which has a very nice interface and as if you like, an engineering approach to respond to the problem of estimating the land surface moisture. As I say, the focus was on hydrological engineering and hydrological applications, but the result is a system that provides an estimate over the entire land surface based on a fairly sophisticated model of the availability of soil moisture in the landscape. So it's a different approach to some of the others we'll talk about in a minute, but it is comprehensive and it's more closer to reality than the systems that we currently use in fire weather. So the other thing that is a new system over the last few years is as many of you will know, the Bushfire Natural Hazard CRC's Land Dryness project has developed a weather prediction model-based system called JASMIN, which has data available in near real time, not as regularly available as the Aura system, but as a research system is updated less frequently. That data, by the way, is very kindly hosted thanks to Marty Yebra and the ANU on the Australian Flammability Monitoring System web pages. So you can see a couple of the outputs of the JASMIN system there. As I say, it's updated reasonably regularly, but not in real time. So the basis for using something like a weather prediction model for estimating soil moisture comes back to what you're trying to do, or what we're trying to do with numerical weather prediction models in general. We're creating a grid around the surface of the Earth and building up a picture of what the atmosphere is doing within each of those grid points, both horizontally and vertically, shuffling air around the planet. Part of the problem of the atmosphere is that you also have to take account of the moisture content of the air. So you need to be able to account for moisture transfer from the oceans into the atmosphere, from the atmosphere onto the land, from the land into the atmosphere, and so on and so on. So in order to get a weather prediction model to work properly, all of these factors need to be taken into account and accounted for in a fairly comprehensive way. And importantly, you need to have a good understanding of the current state of the atmosphere and the Earth system generally before you can extrapolate to what's going to happen in the future. So there are a vast number of observation platforms that are used to provide that initial state of the atmosphere, from satellite platforms, which actually produce most of the information that goes into the models because there's just so much data that's available. The Bureau ingests, I think, something like 8 terabytes of satellite radiances every day in order to constrain the state of the atmosphere. But there are also a large number of other observation platforms that are really important, from drifting buoys to aircraft to automatic weather stations, the upper air sounding network, and so on. So huge amount of background data that amounts to being sort of hundreds of millions of observations over many days, and hundreds of millions of calculations that are done in order to understand what the effect of the atmosphere and the systems that are abutting against the atmosphere, if you like, the oceans, the land surface, the ice. So all of those processes account for fluxes of momentum and energy and moisture between the land surface and the atmosphere. So given that, it makes sense then to ask, well, can we use the land surface part of the numerical weather prediction model to represent soil moisture so that it would be useful for emergency management, and in particular, in this case, fire management? And the answer is, as the project, the Land Dryness project suggested, well, yes, you can certainly observe the state of the land surface better than the current models that we've been using for decades, and you can do it in a comprehensive fashion, and even better, you can forecast it into the future. So the project, the CRC JASMIN or Land Dryness project itself had a number of questions to address. One of them was, does a system like this work? And the answer we've just got is yes. Can we rescale it so that while it improves on the current system, it looks sufficiently like the current system to be used with the the fire behaviour models that are currently used? And the answer again is yes. And Vinod and Imtiaz, mainly Vinod, did a lot of work to rescale the JASMIN system so that instead of, if we go back up to the previous diagram, what the soil moisture system in the numerical weather prediction system has is this 4-layer accounting system of where the moisture actually resides in the soil profile of the model. And that 4-layer system talks about the volumetric moisture content of the soil. So how many kilograms of or how many cubic metres of water per cubic metre of dry soil is there in any particular part of the profile. That's quite a different measure to how much water do we need in order for or how much rainfall do we need in order for the soil to become saturated, which is the, if you like, the bucket model of, say, the Soil Dryness Index and the KBDI. So they're quite different things. And so asking this question about rescaling is quite a pertinent question. And the answer is yes, but there's a lot of tweaking required of the JASMIN system, and to compress the 4 layers of information down into a single number does actually distort the information that you're providing in particular ways. There are a couple of different approaches you can take in order to squash that information into a figure that looks like a pseudo SDI or a pseudo KBDI, but whichever way you do it, you're losing information. So it becomes a matter of, okay, what information can we afford to lose? What's the least important bit of information for any particular application? So that's something that was demonstrated that, yeah, we can do it, but do we really want to, or should we be looking to change the fire behaviour models that we're currently using so that they can better accept the information, the richer information that's available in something like JASMIN or maybe Aura, which has the same sort of approach of looking at separate layers within the soil profile. Another really important question is, okay, can we downscale to higher spatial resolutions? If you like, the native resolution of the JASMIN and the Aura system is 5 kilometres. So it's a fairly impressive thing that you can have a system that pretty accurately represents the behaviour of soil moisture across the continent of Australia as validated against the relatively few soil moisture probes, 80 or so, that are available around the country. These systems work pretty well against those observations, but their resolution is fairly broad, considering the the variability in topography and the variability in soil moisture, which, you know, as I'm sure most of you know, it occurs on a very fine and certainly sub-kilometre scale. So it's a reasonable question to say, okay, can we do a downscale to, for argument's sake, 1 kilometre resolution? There was a lot of effort expended in the project to answer that question. And again, the answer, it turns out to be yes. You can actually downscale to a kilometre. You need to make pretty clever use of satellite information, remote sensing information, of which there's a certain amount, but even that information is fairly coarsely resolved. It's generally of the order of tens of kilometres. So you need to do a fair bit of work in order to get useful output. But the answer to the question is, well, yeah, you can, but the project itself showed that was a demonstration rather than something that's, you know, operations ready. Related to that is, and related to being operations ready, is, you know, can we use this system or a similar system in association with a product or a framework that NASA has developed called the Land Information System? And the idea of the Land Information System, which the Bureau is looking at implementing for its numerical models, or the land surface component of its numerical weather prediction system, and that the UK Met Office, which we collaborate closely with, is also looking at implementing. You know, can we use this NASA system to facilitate the whole process of soil moisture, assimilation of data, so getting the initial state right, and then forecasting going forward? And again, the answer is yes. And there are, and this was part of the project. It was some work that IMTIAS and Vinod did over the last year, and in particular, they went to the US and attended a workshop on the use of the Land Information System, the LIS. And there were a few really important things that came out of that work and that consideration. The LIS is now running on the National Computing Infrastructure in Canberra, and we're looking at importing it into the Bureau's operational systems. But a couple of key things came out of it. One is that it kind of automatically allows you to do the downscaling work that Vinod investigated. So there's capability within the list to do the sort of interpolation that he investigated, which is great and important. The other important component of the list is that the assimilation of things like important measures for soil moisture calculation and monitoring, including satellite radiances. So there are a number of satellites that directly measure radiation that is a proxy for soil moisture content, or at least the top layer of the soil. That important satellite information is naturally handled by the Land Information System, by the LIS. The lack of ability to automatically ingest that sort of information is one of the reasons why JASMIN isn't run on a daily basis. It can kind of work, and then something will change and it'll fall over and have to be restarted manually. The LIS just handles all this stuff without having to involve people. So it's seen as a really valuable thing that the Bureau will implement anyway over the next year or two, that will lead to better, well, better numerical weather prediction models, but also better land surface information. but also higher resolution land surface measures that, you know, that might be based on a JASMIN system, but you can also run AURA, as we discussed earlier, within that land information system framework. So there's some really nice work that resulted from that. Finally, the last bit of the project was, we all know that, as I said at the start, that soil moisture is important for fuel moisture, but we can't really quantify that, or we couldn't really quantify that easily. So the last part of the project that BNHCRC in particular investigated is, okay, what's the quantitative connection between soil moisture and fuel moisture? And the answer, as it turns out, this particular answer is averaged across multiple fuel types across the whole of Australia, is that the soil moisture is actually a pretty good predictor of and well quantified predictor of fuel moisture a few weeks ahead across Australia. It works really well with things like grasses and shrubs. It works less well with fuels that are, if you like, more hidden from the atmosphere, like forest fuels. There's an interface between the, you know, a more complex interface between the land surface and the atmosphere when you've got a 30-metre forest involved, and so it works less well there, but it still works quite well. And this is really important because it now lets us start to answer questions like how do we forecast grass curing, for example, which is something that we will need to do in the Australian Fire Danger Rating System climate module, which is being spun up at the moment as part of the Bureau's work to implement the AFDRS. We didn't actually have a method for forecasting curing in the forecast system that we currently have. Curing is an observed value and it just propagates forward for a few days. You know, if you observe the curing today is 7, we assume it's 70% curing, sorry, a few days hence, because it probably won't be much different. But when you're talking about 3 or 4 weeks ahead or 2 months ahead, then you just can't make that assumption. And the work as part of the Land Dryness Project offers us a method of potentially forecasting that curing and enabling us to predict grass curing and hence predict fire danger likelihoods out, you know, on a seasonal timescale, which is really critical. So perhaps that, you know, in the short to medium term might be one of the key outputs of this project. And just to illustrate that a little bit, I grabbed a plot from the final report of the project. The JASMIN project has finished now within the CRC. But what you can see is that in somewhere like Cumberland Plain, I can't remember where it is, but I think it's a fairly an area with largely grassy type fuels. You get a very strong correlation between the observations, which are those blue plots in the top diagram, and the brown, which is the modelled fuel moisture content. And you can see that follows very closely what's going on in the observed value, with somewhere like Warra, which is in southeast Tasmania in the sort of tall forest that I mentioned before, you can see the pattern of the brown modelled output is quite similar. It follows the major peaks and bumps of the observed data quite well, but it misses out on the spikes and the sharp changes, and so the correlation is substantially lower. But it's actually not too bad when you look at it overall. And as I say, that's really promising for efforts to forecast fuel moisture, and of course, forecast flammability. So that's essentially what has happened in the land dryness soil moisture area in the research project that the CRC has commissioned over the last few years. So we've looked at what soil moisture, why bother looking at soil moisture in the first place, what its importance is. We've looked at the historical measurements that were made, the constraints on those, and how it was that we ended up with the system or several systems that are running today, whether they be point-based systems or gridded systems that are based on those point observations and point methods of calculating, moving to systems which are essentially grid-based and using a broader set of data through to a full NWP, numerical weather prediction based system which incorporates in a sophisticated way all of the fluxes of moisture and energy and momentum in the system. And potentially we will be looking at implementing the NWP based system over the next probably 5 or 6 years is the plan within the Bureau. It's a complicated thing to do, and it requires a number of steps to proceed it, some of which have occurred within the project, such as the land information system that we spoke of. But also there's the opportunity to use some of those research outputs more immediately and in a more focused way, and in particular, as I said, with the fire danger rating system, which we're planning to start trial outputs over the next, not this immediately coming, well, the southern season that we're in at the moment, but the next southern season we'll be running trial versions of the AFDRS weather and climate modules, and the following year, 22-23, those will be the operational systems, and we're expecting to be able to use those research outputs within the AFDRS system in a way that we just couldn't do a couple of years ago. All right, hopefully you found that useful. I'll stop sharing my screen and hand back to Mike for any questions.
Thanks, Paul. Are there any questions? As Ben's just put up, you can either put your hand up or you can type something in the chat. Andrew Sturgis has asked, Paul, did you find a relationship between the FMC and the various veg strata and the layer in the soil moisture profile? And I think you did partly answer that. Yeah, look, partly, but I can go into it a little bit more depth. The plot that I put up showed a sample of some of that difference. What the figure that I quoted about the predictability of live fuel moisture content was average over, as I said, over Australia, over the various veg types, and the various veg types that Vinod looked at were pretty coarse, certainly much more coarse than the
AFDRS veg classification. It's just sort of, I think, grasses, crops, forests, there might have been heathlands or something like that. So quite a broad classification. And as I said, it does work better with those which have a more direct connection between the land surface and the atmosphere. So it works least well with tall forests, but you know, quite to very well with grasslands, for example. And you know, so refinement of that work will enable better correlations in general.
Thanks, Paul. Were there any other questions for Paul?
Paul, Andrew here.
Yeah, hi, Andrew.
G'day. Since no one else is asking, I'll keep on that question.
Sure.
The relationship between the different levels in the soil profile and the different strata in the vegetation. So you'd think that the top 10 centimetres would be more closely linked, say, with grass curing, and maybe the deeper levels in the soil profile will be more relevant to taller vegetation with deeper roots.
Yeah, sure. And that's sort of what we're seeing, or what Vinod saw, and in fact, exactly that sort of relationship is already being used in Neil Burroughs' spinifex fire behaviour model, which is one of the big 8 fuel classifications in the AFDRS, and it's sort of what is expected. Interestingly enough, the work that Vinod did focused most on, or showed strongest results anyway, for I think it was the 0 to 35 centimetre, the combination of the two top levels in the AFDRS. In the JASMIN system. But we've been talking to the Aura people, the Aura hydrological modelling team, and because they've got a system in place at the moment, we're looking at the possibility of piggybacking off that to provide input for this curing information for the AFDRS. And Aura have a 3-level classification, as I mentioned, and the top 2 layers are basically 0 to 10 centimetres, and then the remaining distance to 1 metre. And they've been able to pretty much replicate Vinod's findings for the more shallow soil profile. So it seems to be that while the skin, if you like, the top 10 centimetres is really important, there's still a lot of value in that the rest of the depth down to 1 metre, even for grasses, which you expect to have a much, and do have a much shallower root system than forest areas. Whether that's because there's a flux of moisture which naturally goes backwards and forwards in those top 2 layers, I'm guessing is the case, but I'm not really qualified to say.
There's a question from someone called Stromlo. How useful would information from soil moisture probes connected to weather stations in the field be to supplementing or validating what the work you've done?
Yeah, look, it's something that we've been discussing with a couple of groups, and the particular case in Tassie is that there's a probe attached to a sensor in Western Tasmania in the organic soils there, which potentially is going to be really valuable for ground truthing in that sort of area and that sort of soil, because it's apparently organic soils are not well represented in the models, and there's a lot of potential for improving their representation. But in general, as I mentioned, across Australia, there are only about 80 long-term observation sites that we've had access to. So potentially more observations will allow us to constrain the model much more closely in a way that we haven't been able to at the moment.
And a follow-on from that is what depth measurements would you be suggesting for soil moisture probes?
Look, I'm not sure, to be honest. I think, given a 4-level NWP model, having ones close to the surface, but also sampling the deeper soil structure, so say at 50 centimetres around there, would be very helpful, and potentially in future the Bureau will be able to assimilate these, once it implements the land information, you'd be able to assimilate these data into the models in a way that potentially can help the broader modelling effort, atmospheric modelling.
Yep, no, I think that was the thinking. Last chance for a question, somebody? There are. That's fine. We've had a few.
I saw a little thing saying Mark's just raised his hand.
Is he? Okay. Is that true, Mark?
I'm trying to play muting and unmuting. Can you hear me, Paul?
Yeah, I can now.
Oh, good. But you don't have to look at me. That's handy. So, looking at your example of the Cumberland Plains versus the Warra, the Cumberland Plain, at least the one I know, of course, is in the Sydney Basin, as opposed to probably are others, not least in Cumberland. You've got the difference in the vegetation, and how much of that inability to predict is based on the technology, which is using reflectances, as opposed to maybe another technology that might use active sensing. Do you have any feeling for any emergent remote sensing technologies that we can use to get under the canopy, so to speak?
Look, not really is the short answer, but I'm not a remote sensing specialist, so there may be a host of answers, and somebody like Marta or Karen Reinke or Simon Jones, who've been involved in the CRC in remote sensing of vegetation characteristics, would probably be able to roll off half a dozen options off the top of their head, but I don't really have a strong feeling, but I know that they're working on things like that.
Cheers.
I think that's probably it for now. So thank you, Paul. There's certainly some very exciting work that you and Vinod and others have been doing. Certainly far exceeding the delights of Keetch, Byram and SDI. So we look forward to that being implemented through AFDRS Sounds quite exciting.
Yeah, look, I think it is. Thanks, Mike. You know, I cited one example because of how we can potentially apply this stuff, because it's been on my mind and I think it's immediate. But I think, you know, further down the track as we develop, you know, fire behaviour models more, you know, I think there's a much greater capacity to exploit this information source, if you like.
Yes, and it certainly it's another piece of information that we can use in the fuel moisture equation. That's always a challenge. So that will be quite good, particularly in those fuel types like mallee and heath, where we know there's a fuel moisture issue there, but it's not there. It's almost like an on-off switch, and trying to calibrate that will be quite useful to have better metrics.
Yeah, certainly. And look, the other thing that I didn't say, because it was, you know, it's running in parallel, but to the JASMIN project, or actually an extension to the JASMIN project, is that the CRC have funded some work to use to look at 5 of the fires that occurred over last summer in different jurisdictions, through the lens both of Marta's work from the fuel moisture side of things and from the soil moisture side of things from JASMIN, to identify what insights could we gain that potentially will be useful both immediately and in future seasons. So I think, you know, there's a lot of potential from that as well.
Yeah, that's excellent. Thank you. That's the end of this year, and we tentatively will start up again in late to mid-January. We will send out notification of the next webinar, tentatively the 20th of January, but it's not confirmed yet, so I won't promise anything just yet. Yeah, thank you very much. Everybody have a safe and quiet Christmas, and we'll see you in January again. Thank you.
Thanks, Mike. Thanks all.